we've seen some drones, a bunch of quadcopters, a number of other things besides normal fixed-wing planes, but I have not seen anything like this. So Stjohn Youngman from Skyfly Technologies is going to take us through. Tell me, what do we have here? This is a rather unusual craft.
Hey, so hi everyone, this is the Axe. So this is Skyfly's Axe. This is our proof of concept aircraft. This is the aircraft we built to make sure that this concept works. So effectively it's a canard layout aircraft, and at the end of each canard we have our pylons, and we have a propulsor at each corner. So what we've tried to do is blend effectively a quadcopter architecture with a fixed wing aircraft architecture, so that we can have a much more efficient cruise but still have the ability to take off and land vertically.
Now, when I came here I was thinking, oh God, well that's kind of cool, but it's gonna be a lot of like technology and mechanisms to tilt the rotors. These are fixed rotors.
Yeah, exactly. So the reality is aerospace design is about trade-offs, and what we felt, having a fixed rotor position meant we avoided the mass and the complexity and some of the safety issues and reliability of a tilting propulsor.
Right.
What you actually find is having the fixed 45 degrees, pitching the aircraft back for vertical takeoff.
So to take off, to go vertical, the software will add more thrust.
More thrust on the front rotors compared to the rear will pitch the aircraft onto its tail. So the tail is designed to take the weight of the aircraft. So you sit back on the tail, the propulsors are then pointing vertically. That enables you to do the vertical takeoff and then pitch forwards into a transition.
Now when I was talking with them yesterday, these are dual winding motor. There are actually two motors in there.
Yeah, exactly. So we recognise that obviously one of the challenges of quadcopter is you only have 4 propulsors. So we want to make sure we never lose one of those propulsion systems. So we're doing that by having effectively a 2x3 phase motor on each corner. Each of those electric phases effectively is powered by a different battery. So we have the ability to sort of independently power them. So any one battery failure doesn't create a loss of thrust on any one corner.
Okay. So you can take, once you've established vertical flight, you're up, you make a translation, and I was told yesterday 80%, the wings will support 80% at what speed?
Yeah, it's about that. So with the propulsor always being at 45 degrees, there is always some lift derived by thrust.
Sure.
But in the cruise, it's very minimal. So we have actually quite a lot of wing area. We're able to produce a lot of lift at quite low airspeeds. So in the cruise, we only need about 60 kilowatts total to achieve our sort of cruise.
And what can this puppy put out when you get the batteries grinding?
In the hover, it's much more. So we're up at about 260 kilowatts, so over 300 horsepower. So,
but you can cruise at 60 kilowatts.
Yeah, 60 kilowatts. Yeah, so that's showing us that you need the wing to get to efficient flight, and that's one of the challenges of the endurance we'd have as a quadcopter would be much, much lower.
And so this cruises, I believe you said, at 100 miles an hour?
Yeah, up to 100 miles an hour. You can, obviously, like in all aircraft, there's a trade-off between cruise speed and range and all of that good stuff.
So at a reasonable speed, you get an hour plus reserve?
Yeah, exactly. So yeah, about an hour is our sort of customer launch target. This is our proof of concept, so it's a little bit beneath that at the moment with our off-the-shelf system, but that's why we're developing our own electric propulsion system, and we've got our own battery system in development. We're working with a great motor partner. We're actually looking
at who they are? Or?
No, not at this stage, so we want to keep that. We're putting a lot of effort into them to get them up to speed, and we're actually going to be offering some of these components as to secondary manufacturers as part of a propulsion offering.
I think that this is a very big thing here at Sun and Fun, where there are a lot of experimental aircraft people.
Yeah, exactly. So
you'll actually be selling components to the experimental market.
Yeah, exactly. So we're going to so the Mosaic regulation change around LSA is really opening up this market, and we anticipate it gives us the ability to bring this aircraft to the USA, but also we think there are going to be lots of other electric aircraft that become viable under Mosaic changes. So we're spending a lot of time and effort developing what we think is great hardware. So we're going to have a world-class battery system and a fantastic set of propulsion motors.
And you can lift 200 kilograms. 200 kilograms.
So yeah, so 100 kilograms is for each pilot and passenger. So yeah, around about 200 pounds per seat.
Now, the other interesting thing about your hybrid configuration is if you have a complete power failure, you can glide, and exactly.
So we're big proponents of the technology that we're using. However, aerospace, especially in early technology phases, you have to be respectful of the failure modes that can happen, which is why we have a completely mechanical flight control system. So when you're in the cruise, it's a regular plane. You're a stick and rudder aeroplane. It's as simple as it gets. And if you had a complete loss of thrust, which although we're designing to be incredibly unlikely, but it is always possible, it's just like a Cessna 182. There is a forced a field landing procedure that you fly. You have a speed to fly, and then you pick your field or you pick your highway wherever.
Just like I was taught in my Cherokee.
And although we have a reasonable glide rate, a glide ratio, it's very manageable. We've actually tested this. We've done a few of these tests in our early sort of prototype test flying days, just to make sure that we understand that the aircraft is reasonably flyable in a forced landing configuration.
Right.
So,
and I believe you said yesterday, and I just want to verify, did I hear your stall speed is 50 miles an hour?
Yeah, around about that. So it's going to depend on a few other things. So yeah, it's reasonably slow.
It's within the grasp of a normal pilot.
Yeah, normal pilot. Remember, it's a canard configuration, so it's a very safe stall. I.e., you run out of pitch authority before, and the nose keeps nodding away. So it's a really benign stall characteristic. So we're pretty happy with that. But it's one of the reasons we're flying this aircraft. Right. We're tuning things. We've got some aerodynamic devices on the elevator here. We're always figuring out how to make the aircraft a little bit more optimal. Obviously, we've got lift devices we can play around with. So yeah.
So now, when do you think you'll be entering production?
So we're designing and building our production specification. That's what we're doing at the moment. So basically the outer mold line has stayed the same for the production spec, which we're really glad. So all of the work we put into this aircraft carries over, but we are improving the fit finish quality, change of some materials. We're going to a true sort of aerospace pre-preg for the whole aircraft structure.
Pre-preg carbon?
Yeah, pre-preg carbon, and obviously propulsion system upgrades, and then we're preparing for our first customer deliveries in 2027. So yeah,
that's exciting. Ambitious.
Yeah, it's ambitious, but we're moving quickly. We're scaling up in the UK. We're building our presence here in the US. So Sun Fun is a really great opportunity to get ourselves sort of amongst the American public.
This is fabulous. There's probably only a couple more. We got to production, so before 2028 we can see a few of these flying, and of course now. Everyone will want to know, how much is this?
Yeah, sure. So our pricing's 400,000 is our base model pricing. There are some options in terms of colours and finish and interior that people can do, but most aircraft will be around that 400,000 mark.
So the weird thing is that is below the cost of a normal trainer plane these days.
Yeah, exactly. And so there are some balances. So fundamentally, it's a pretty simple aircraft. It's a day VFR aircraft, so from an avionics point of view...
We're not going to be doing instrument training.
Yeah, we have our avionics package, we have a Garmin backup system, but fundamentally it's a nice, simple aeroplane. We're trying to bring it in at a competitive price. We think that's fair for a factory-built aircraft.
I think that's great, and I'll just mention it here. I did see that you also have a potential military and first responder application. Since you can do rescue, you can do delivery.
Yeah, exactly. So with the aircraft having a digital flight computer, we're very capable of flying this aircraft unmanned, and that offers a lot of opportunity in the defence. And as you mentioned, medevac, 200 kilograms of payload is a significant amount, and we see lots of applications where people want to use that. So we have this aircraft in development. We can change the fuselage pretty quickly and keep the layout that we have. We're also working on a hybrid electric version of the aircraft as well.